Hello, I'm Julie Lerman. Welcome back to Entity Framework Core Fundamentals. In this module, you'll learn more about the most common type of relationship, one-to-many, which we already have defined between author and books in our model. In order to help you visualize how EF Core is interpreting these setups, we'll start by installing the EF Core Power Tools extension for Visual Studio, which I've mentioned a few times already, and you'll learn how to use its visualization feature. Then we'll take a closer look at that existing one-to-many relationship, and you'll learn about the various ways you can define a one-to-many relationship that EF Core will recognize. I'll explain the benefits of having a foreign key property in your dependent classes, and we'll add author ID into the book class. With the author ID property in place, you'll learn more about the Has Data seeding feature that can also be used to seed related data. With these in place, we'll be creating a new migration and update the schema of the database. Then, before wrapping up, you'll learn a few more tips about foreign keys in the DB context. So let's get started. Before digging into the one-to-many relationships, I want to share with you a really important tool that will let us see how EF Core is interpreting the data model and these relationships. Remember that EF Core has a set of conventions that it uses to determine how to translate your entity classes into database schema. But those conventions don't always align with our intention, and we can use a rich set of mapping APIs to override those conventions when needed. Most commonly, we do that in the DB context using the Fluent Mappings API, which is part of Entity Framework Core. A subset of those mappings can also be described in your entity classes using data annotations. But I much prefer the Fluent Mappings because I personally don't think that my business classes should need to know anything about the database. It's not uncommon for EF Core to interpret the mappings differently than you had intended, which is why being able to visualize how it's interpreting your data model is really important. I'm so grateful for the Visual Studio extension created by my friend and Microsoft MVP, Erik Ilskov Jensen, called the EF Core Power Tools. The extension has a lot of features, which is why I've mentioned it a few times already. But here I'll focus on its ability to let you visualize how EF Core will interpret the model described by the DB context and classes. The visualizer in the Power Tools relies on Visual Studio's DGML editor extension, and there's a good chance you already have that installed, but if not, the Power Tools installer will also install that extension for you if it's not there already. I already have the Power Tools extension installed in Visual Studio because I use it so much. The extension also relies on the EF Core design package being in the same project as your DB context. This is the same design package that the Tools package we installed for migrations into the console app has a dependency on. But for this task, we need the design package explicitly to be in the data project as well. So there it is. With that set up properly, now I can right-click on the project where the DB context lives and choose EF Core Power Tools and then Add DB Context Diagram. I love this extension, and I'm so grateful to Erik for creating and maintaining it. This visualization is saved as a DGML in the project, and it defaults with the same name as the context. Now I can see how EF Core is interpreting my data model based on what I've told it about the DB context and the classes. Notice the dark red author block in book, which the legend that I've enabled by clicking the legend button at the top of this window tells us is a navigation property. In the author class, you can see the navigation collection property, which is the list of books. In between the author and book classes, there's an arrow indicating that there's a relationship between them, and next to it a notation, 1:**, which is shorthand for expressing one-to-many. It's not uncommon to discover that EF Core is inferring your model differently than you had intended, which usually means going back to the DB context class to tweak some of the mappings. I'll be using this tool a lot in this module to help explain how EF Core is interpreting various changes that I'll make to the author and book classes. One-to-many relationships are probably the most familiar type of relationship. And these are more fondly known as parent-child relationships, although parent-children would be more technically accurate. An author can have many books, and I'm using list properties, such as list of book, to represent the children, though you could use another type of collection if you prefer. Recall that when I scaffolded the database, EF Core defined the books property as an I collection, not a list. EF Core has a set of assumptions that it makes about the classes in a data model. These are the defaults or conventions that I've referred to before. We have a paradigm in software called convention over configuration, which exists to reduce the number of decisions a developer needs to make. EF Core has a lot of conventions, which you can override with explicit configurations as needed. Let's look at those conventions for one-to-many relationships. Keep in mind that the way a one-to-many relationship is represented in the database is that a row in the child's table has a foreign key column pointing to the parent, and there's a constraint defined between them. For example, the books table has a foreign key column called author ID, even though I didn't create an author ID property. The list property, or some type of collection in an entity, is enough for EF Core to understand that this is a one-to-many relationship. The child or dependent class doesn't even need a property with any reference to that parent. And EF Core will infer that if needed, as you saw it do for the author ID that's in the database. This isn't just in how it defines the database schema, but it will take this into account when creating SQL and when materializing objects from query results. EF Core's ability to infer properties in the data model that don't exist in the class is referred to as shadow properties, and you'll learn more about those later on in the course. It's a bit advanced, some under-the-covers stuff, but an important feature to be aware of. My book class does have an author navigation property, but I'm going to comment that out temporarily so you can see that EF Core still recognizes the relationship. And the visualizer shows that. EF Core is aware of the relationship, even though the book class knows nothing about the author class. Let's look at some of the other conventions EF Core recognizes in combination with the list of children in the parent. If the child has a property that is the same type as the parent, so in this case, the author property, then it's also understood to be part of that relationship, and it allows you to navigate from the child object to the parent object in your code. I've uncommented the author property, so now that's part of book again. Again, the visualizer shows that EF Core is aware of the relationship, and if I hover over the author property in the book entity, it does say that it's a navigation property. The child can also have a property that's a foreign key back to the parent. In other words, the key value of the parent. Thanks to the list of books in the author class, EF Core is already aware of the relationship. So it will keep an eye out for a foreign key property in that child class that's either the name of the parent, author, plus ID, or the same name as the parent's key property. Except in the case such as ours, where the parent's key property is simply called ID. And there's nothing wrong with a key property being called ID. You just can't have a foreign key property called ID. Although you could always add some special configurations if you need to do that. So the author ID property does match the first convention, and EF Core knows to map this property to the foreign key column in the database table. So I've messed with the author class again. I've commented out the author navigation property and added in an author ID int property. And the visualizer now recognizes our author ID property as a foreign key. And we know it's a real property in the class this time, not just something that's inferred in the data model. Later in this module, I'll show you what happens if you have an unconventionally named foreign key and how to fix that in the data model. Here's an example where you get to have your cake and eat it too. Again, EF Core is already aware of the one-to-many relationship thanks to the list of books in the author class. But I also have both an author ID property and an author reference property in the book class. And I would set it up this way if I do need to take advantage of both when I'm coding. To drive this point home about the list in the books class, here's an example where I don't have that list of books in the author class, but I do have an author ID property in the book class. EF Core will not realize that this is supposed to be a foreign key because now the authors don't know anything about the books. Its convention is that it relies on that list or collection of books in the author class in order to even think to look for the foreign key. I've commented out the list of books in the author class so you can see the effect of not having that in the principal type. So in this example, EF Core will not detect any relationship. While I won't be spending a lot of time on custom mappings in this module, I do want you to realize how much you can achieve with them. So I just want to show you quickly that it's even possible to add a configuration into the DB context to make the data model aware that there really is a relationship between book and author, even without any navigation properties. This is what that configuration would look like in the pub context on model creating method. I'm telling the model builder that even though the author entity doesn't have a book's property, it does have many of the book type, and then that book type has one back to the author. This particular use is a bit advanced, so I'm not going to dig into it, but I just want you to know how powerful the mapping API is to let you override the conventions when you need to. And here's the data model again, showing that even without the navigation properties, and thanks to the mapping, EF Core does recognize the one-to-many relationship between author and books and will expect the database to have the relevant schema.